Hey everyone, it's Mr. Smith here. Going ahead and starting a new topic today. One that I've already shown the students earlier, but I wanted to get the video up already, so let's go ahead and get into this. What we're doing now is we are learning how to create strip diagrams and equations from word problems involving addition and subtraction. When we were growing up, when we were solving word problems, it was basically gathering the information and just solving the word problem out. It's a little bit different nowadays. Rather than trying to find just the answer to the word problem, Texas now wants students to be able to show the setup to the problem rather than the answer. And you're going to see what I mean by that in just a moment. But before we can do strip diagrams and equations, we must understand what they are. So, to start things off, a strip diagram is a visual representation of a given problem or scenario. In the strip diagram, the unknown quantity is represented by either a question mark, which we all know what a question mark looks like, or a variable. Now, variable might be a new thing for students in 4th grade because now in 4th, even early as 3rd, they start getting introduced to variables and a little bit of elementary algebra. So before we begin, we must know what a variable is. A variable is a symbol, usually a letter, that represents an unknown quantity. So, if you're wondering what that means, in the following equation, y equals 4 times 9, the letter y is the variable. This right here represents our unknown. But if you know your times tables, 4 times 9 is 36, so in this case, y would be equal to 36. So y was substituted for instead of the 36 to show an unknown quantity. Now, an equation is very simple. It's a mathematical statement that contains an equal symbol. So if I wrote something like this, 3 times 5 is equal to 15, this symbol right here immediately makes it an equation. I always tell the students, equation equal symbol, equation equal, they both start with an E. So a little way to remember how that works. So we're going to go ahead and look at 2 word problems that involve us having to make a strip diagram and to create an equation. So, number 1. Mark has a collection of 238 rocks. He then finds another 83 rocks for his collection. Draw a strip diagram, write an equation, then solve for the total number of rocks. Unfortunately, I don't have my color pencils with me, so I can't do the cube strategies with coloring. So I'm going to have to just use my regular blue pen. So my apologies, but we have to work with what we got. So I'm going to circle, like I said, in cubes, 238 rocks. And I'm also going to circle 83. Now, U stands for underline the question. But if you notice here, there's not really a question statement. So it also stands for underline what it's asking to find. So I'm going to underline draw a strip diagram, then write an equation, then solve for the total number of rocks. One moment, please. It's a little... There you go. Now, I need to draw a strip diagram, write an equation, and I'm looking for, key information, the total number of rocks. Total tends to mean addition. So I think we're going to be doing addition in this problem. So let's go ahead and draw a strip diagram and show how this works. So a lot of us have never seen a strip diagram, so it might seem confusing at first, but it'll make sense in a bit. First thing we're going to want to do, you're going to want to draw a nice sized rectangle, give it a good amount of length, then cut the rectangle into 2 horizontal strips. Now, you're also going to want to put an extension here for a reason. Now, to explain that reason in a bit. Now, on the top is your total, and on the bottom are the parts that make up the total. But since we don't know our total, I'm going to go ahead and put a question mark. I don't know what it is. So, but I do know this though. I originally had 238 rocks, and then I found another 83. I want to find the total number, which is these 2 together. So I want you to make the extension, and I want you to put addition, multiplication, subtraction, and division. The reason why we do this is whenever we're dealing with the total, it's either addition or multiplication. When we're dealing with the parts that make up the total, we're either dealing with subtraction or division. In this case, we don't know what our total is, so we can say goodbye to subtraction and division. We don't need those. But we need to find out, is it addition or multiplication? It's real simple. In addition, the parts are two different numbers. However, in multiplication, all the parts are of equal value. So what that means is, in order for it to be multiplication, these two parts either had to have both been 238, or they both would have had to have been 83. But since they're two completely different numbers, they are not equal parts or equal groups. So multiplication's gone. We know it's going to be addition. And that right there is the strip diagram. The top part representing the unknown part. This is the two parts needed to get this part. Now, if I draw like a little linking staple, like a make-believe staple, we can kind of say that these two together are the same length as this. So that means that if I add these two numbers together, I'll find the unknown. Makes about sense. Now, to make the equation, since we're talking about rocks, I'm going to go ahead and use R as my variable. So in order to find R, I'm going to say that I have to add 238 plus 83. Okay, so I'm going to go ahead and do that, because I know it says we've already got the strip diagram, we wrote the equation, now we need to solve. So 238 plus 83. Split your place values. 8 plus 3, 11, carry your 1. 1 plus 3 is 4. 4 plus 8 is 12, carry your 1 again. 1 plus 2, 3. So, Mark now has 321 rocks in his collection. A little confusing, but I do know the students are becoming very, very familiar with this, and they are showing to me that they are able to make these themselves, which is really good. So, let's go ahead and look at one more to get the idea of how the strip diagram works. The first one involved addition. So, let's see what this next one says. Martin bought a bag that had 149 pieces of candy in it. On his way home, the bag ripped. 38 pieces fell out of the bag, then another 25 pieces fell out a while later. Draw a strip diagram, write an equation, then solve to find out how many pieces of candy Martin had when he got home. So, let's go ahead and circle our numbers we need. 149 pieces of candy. We know we might need 38, and we might need 25. Now we need to underline what we're looking for. We are looking for a strip diagram, writing an equation, and then solve how many pieces of candy Martin had when he got home. Well, if pieces are fell out, that tells me that we're losing candy. That sounds a little bit like subtraction to me. So, those are our keywords fell out. So it sounds like we're going to do subtraction, but we want to draw our strip diagram to go ahead and test this out. So, I'm going to draw a nice long rectangle. I'm going to cut it into horizontal strips. I'm going to extend it over to the side. I'm going to write addition, multiplication, subtraction, or division. Well, he originally had 149 pieces of candy, so it sounds like he had a total amount of 149 pieces of candy. So we do have a total, so we can already say that it's not going to be addition or multiplication. However, it does state that at one point the bag ripped and he lost 38 pieces, and then a short while later he lost another 25. Well, there's this whole chunk of the bottom strip that we're missing. So couldn't we put a question mark there? I would, because we don't know what it is. But since we are missing a part, that tells me that it's either subtraction or division. How can you tell? Well, just like in multiplication, in division, all the parts would have to have the same amount in each part. And if you noticed, 38 and 25, from my point of view, those aren't equal numbers. So they're not equal parts. So it obviously cannot be division. So since we've eliminated 3 of the operations, I guess we're doing subtraction. So there's 2 ways to go about this. And I'm actually very proud of my students because they're actually able to tell me the 2 equations. It's amazing just how my students think sometimes. So I've known that they see it one of 2 ways. They tell me that they take the 149, they subtract the 38 first, then they subtract the 25. Or what they do first is they add the 38 and the 25 first, then they subtract it from 149. That's why it shows that there was 2 possible equations that you could have obtained from this. Most people do not see, are unable to see that. So for your children to be able to catch that fairly quickly, I have to give them major props. So good job, guys. Now, since we now have the strip diagram and the equations, let's go ahead and solve it. And I'm going to go ahead and I'm going to use the second equation, what it's telling me. So in step 1, this is a multi-step problem. I'm going to take 38 and add the 25 and get a total there. 8 plus 5, 13, carry my 1. 1 plus 3, 4, 4 plus 2, 6, 63. Then in step 2, I'm going to take 149 and subtract 63 from it. Split my place values. 9 minus 3 is 6. Not enough, so I've got to regroup. 14 minus 6, 8. So that means at the end of his walk home, Martin didn't realize that he lost nearly 63 pieces of candy, nearly half the bag, and now he only has 86 pieces left. Still a lot of candy if you ask me, but still, it'd be nice to have those other pieces of candy rather than have them get lost. Anyway, this has been strip diagrams and equations involving addition and subtraction. Parents, if you have any questions, again, please contact me on Class Dojo or contact me in my school email, which is on the school website. If you have any questions, please do. Thank you and enjoy the rest of your night.